Hey everybody, today I'm going to do selected problems from the Unit 2 review to help you prepare for your test. So starting off with number 1, when we see a limit definition of a derivative kind of problem, the first thing we want to look for is what is the original function. So you want to look here after the parentheses, after that minus sign I should say. The original function is sine of x. That pi over 3 is asking us to find the derivative at that point. So this would be, if we find the derivative of this, think about your SC, negative S, negative C. So the derivative of sine is cosine. And then we want to find that point at pi over 3. So we're doing cosine of pi over 3 to find our answers. So first figure out what the function is, take the derivative of that, and then plug in the value that they've given. Sometimes, remember, they just give you a function, and sometimes they ask you to find the derivative at a point. So if you think about your unit circle, cosine's the x value at 1/3, so that's going to be 1/2. So don't forget to memorize your unit circle or review yourself before the first test. Okay, number 2. Here is another, we're trying to find the derivative at pi. So I'm first going to do the derivative. The derivative of x is just 1. The derivative of sine, we just talked about that, was cosine. And then the derivative at pi, we're going to think about cosine of pi, so that's straight to the left. The x value there is -1. So I have 1 minus 1 is 0. All right, the next two, we have a product rule. You should see you have two functions multiplied together here. So we need to do our product rule. And here we have our quotient rule because you can see we have two functions divided by one another. So to do the derivative, I'm going to do the first times d2 plus the second, d1. Then I'm going to find it at 3 pi over 2, which is the coordinate that's straight down. So x is just going to be 3 pi over 2. Cosine of 3 pi over 2, so straight down, my x value there is just 0. Sine of 3 pi over 2, so this is the y value there. The y value there is -1 times 1. Okay, so to simplify this, this is 0 when I multiply these together, and this is -1. Okay, let's practice a quotient rule now. So dy dx, which is just another way of writing a derivative, or we could have done y prime. So we're going to do low d high. Remember the derivative of ln, we do the derivative of the stuff, so the derivative of x is just 1 divided by the stuff. The stuff is just x. So ln is one of those special ones when you know. Derivative of the stuff divided by the stuff. So whatever's there is going to be that. Okay, so I have low d high minus high d low, derivative of x, all over low squared. Okay, now I'm just going to simplify. When I have x times 1 over x, that's going to be just 1. That simplifies to 1. Ln of x times 1 is just ln of x over x squared. That's as much as I can simplify it, so we can stop there. All right, this is just another derivative. Notice you're going to do a product rule here. I'm going to let you try this one on your own. Keep in mind tangent, we use our special box there. So think about the tan secant box. So when we do the derivative of tangent, it should be secant squared. And you know ln because we just talked about that one. Okay, number 6. Find the equation of the tangent line. You should see, find the EOT in that problem. You want to zoom in and try to figure out what are they asking me to do. So in order to do that, I need the POT, SOT, and then the EOT. Well, I can see My point is right there. This is my SOT already given to me. So this is going to be an easy problem. I'm ready to write my equation. It's going to be y minus, there's my y value. My slope is -1. And then x, there's my x value, which is 2. So that one's pretty straightforward. On this one, we do have another equation of the tangent line. The only difference is they did not give me a full point this time. I have for my POT the x value, but I'm going to need to find the y value. And of course, we can find the y value by just plugging in our function for x. So 4 minus 4, that's 0 minus 3. So that's the point. To get our slope, we need the derivative of this function. So the derivative of this would just be 2x minus 2. Now I'm going to evaluate it at 2. So 4 minus 2 is 2. Okay, now we have enough information to write our equation of the tangent line. Y minus plus 3 when we have y minus a -3. My slope is 2, x minus 2. Okay, this is another quotient rule. I'm going to allow you to do this one on your own. So you're going to do your low d high minus high d low all over low squared. And they're going to give you the values to plug in here. So this one I think you can conquer on your own. All right, let's try this derivative out. So they gave us some values. There's our function. What is the value of h prime of 0? So we're trying to find the derivative first. So I'm going to start there. So remember, we just do each term at a time. This is just a multiplier, so we leave that. So that's 3 times f prime of x when I do the derivative of that. This one is just a multiplier again, so minus 2 of g prime of x. We can think of this as a negative cosine here. 5 is just the multiplier. So when you do your SC, negative S, negative C, negative cosine is actually going to be positive sine. So keep in mind this sign will stay with this. So this will be a plus 5 sine of x. And then the derivative of -3 is just 0, of course, because that's just a constant. Okay, now we're going to plug in our values because we want to find h prime of 0 was what the question asked us to do. So 3 times, I'm looking for f prime of 0. They gave that to us, that's 3. And then I'm looking for g prime of 0, which is 7. And then last I'm looking for sine of 0. So that's the y value when I go to 0 degrees over here. The y value is 0 on my unit circle. So I have 9 minus 14 plus 0. So that is -5. Okay, this problem is very similar. Let's just remind ourselves about e to the x when we do that derivative, because you'll do the derivative of this term, and then 8 is just a multiplier. But remember, the derivative for e to the x is we'll do derivative of the stuff. So derivative of the x is just 1, and then with e to the stuff. So derivative of e to the x will just be e to the x. Number 11. For the function, find the average rate of change. So AROC, average rate of change is just the slope formula that you've been doing since Algebra 1. You know how to do this. So they have given us the x values. Our job will be to find the y values. So I'm going to do f of 4 by just plugging into this function. 4 cubed plus 2 over 4. 4 cubed is 64, minus 2 is 62. Divided by 4, I can probably, oh wait a minute, did I do that wrong? Oh, I didn't add 2. I subtracted 2. Okay, that should be 66. So let's see, I can reduce that to be 33 over 2. Yeah, I can't simplify more than that, so we'll leave it at that. F of 1, I'm going to do the same thing, plug it in 1. 1 cubed plus 2 divided by 1. So 3 divided by 1 is 3. All right, so my slope formula, I want to do f of 4 minus f of 1, 4 minus 1. We've already found these values, 33 over 2. F of 1 is 3. 4 minus 1 is 3. Let's see, I'm going to try to simplify this a little bit more. 33 over 2 minus, let's see, I'm going to make this 6 over 2 so that they have a common denominator there, which will be 27 over 2. And since this is division, I'm going to keep change flip. Remember, we can multiply by the reciprocal here, so this is the same as multiplying by 1/3. This divided by 3. So 27 over 6 can reduce to, let's see, I'm going to divide that by 3. Divide that by 3 is 2. 9/2. Little fractions to work through there, but we can handle it. Okay, part B, the instantaneous rate of change. That's the IROC. So whenever asking for that, f prime of t, they asked me to do t, not x this time. I should have done t here too. Okay, so the derivative of this, I'm looking my original function here, and I'm going to have to do a quotient rule here because I have a function divided by a function. So I'm going to do low d high minus high d low all over low squared. Okay, this is my derivative, and then I'm going to plug in 2. Okay, so I have 2. 2 squared is 4 times 3 is 12, so I'm just going to simplify that a little bit. 2 cubed is 8, plus 2 is 10 times 1, and that's 4. So I have 24 minus 10 over 4, 14 over 4, 7/2. Okay? Okay, we have a piecewise function here. And it says to find all possible values of a and b such that f of x is differentiable at x equals 1. So remember, for it to be differentiable, it also has to be continuous. So those two things will help us find those missing pieces. So let's start with the continuous piece. We know that if they're continuous at 1, then the limit as x approaches 1 from the left has to equal the limit as x approaches 1 from the right. So I'm going to find those values and set them equal to each other first. So from the left, I have a times 1. I plugged in the 1 for the x. Now here I have b times 1 squared plus 1 plus 1. So let's simplify. This is just b plus 2. Okay, so my first clue is a has to equal b plus 2. Now, of course, this is not really enough information for me to find a and b yet, so I'm going to need some more information. So since it's also differentiable, let's find the derivative of this function. So the derivative of this, whatever that number is in front of x, that's going to be the derivative. 1 times a is just a. And then this one, this will be 2bx plus 1. All right, so now I'm going to do the same thing, because if it's differentiable, the limit as x approaches 1 from the left of f prime of x has to match the limit as x approaches 1 from the right of f prime of x. So these two also have to equal each other if it's differentiable. This one will make it continuous. This one makes it differentiable. So a, Nothing for me to plug in here, there. 2 times b times 1 plus 1. That's just 2b plus 1. So this clue tells me that I have another equation. A has to equal 2b plus 1. Okay, so now I have 2 equations. I can write a system, so I just want to cancel one of them. I see if I just change the sign of this, the a's will cancel. So I'll have negative, negative, negative. So b minus 2b is negative b plus 1. So if I move to this the other side, b will be 1. Okay, so now that I got b, a should be pretty easy. I can go to this equation right here to find a. 1, we now know b, plus 2, a is 3. So a is 3, and b is 1. So when you have these piecewise functions, remember the limits from the left and the right have to match for continuity. The limits have to match for the left and the right for the differentiability. And so you just find the derivative and check the limits from both sides. And I'm, of course, using the value where the piecewise function could have a jump, and that's why we check that value. Okay, this one is just wanting you to identify the limit definition of the derivative. You can see the delta x. We've also seen that as h in these problems. So I'm looking to see where did they plug it in correctly. I noticed right away neither of these have the limit, so I know for sure those are wrong. So it's down to these two because they at least both have the limit as delta x is approaching 0. This one I can see that they plugged in the x plus h or the x plus delta squared. They did not do that correctly here. So C has to be our correct answer. Okay, 14 is a rule here. So what we're going to do to find h prime of 2, we're going to do the first times d2 plus the second times d1. Now I'm going to find h of 2. Okay, so I'm looking for f of 2. So this is a point. So let's see, this is my f function, this is my g. So on f, what is the value at 2? That's this point right here. So it is 2. G prime of 2 is looking for the slope on the g graph at 2. So I'm going back to 2 on the g graph. Since it's got the prime, I'm looking for the slope at that point. Well, the slope here, it's going up 2 over 1. So that is also 2. This is asking for the point. So g of 2, the value here is negative 3. And then f prime of 2 is looking for the slope on the f graph. So I'm looking for the slope of this line, which it's going down 1 over 1. So that is a negative 1 slope. All right, just multiply this out. So we have 4 plus 3 is 7. Oh, that was the answer C. I didn't even see it was multiple choice. Okay, g prime of 3, so you're just going to go with the g graph at 3. 1, 2, 3, right here. So g prime of 3, the slope of this is not able to find. It's not differentiable because we have a sharp corner here. We don't know which way the slope would go. So we would say something g prime of 3 is not differentiable because it has a sharp corner. Number 16, they have given us a scenario here, and it is asking us to estimate the value of f prime of 4.5 and explain its meaning. So to estimate this, I look to the table to see approximately which two values this would fall between. And of course, this would fall between 4 and 5, 4.5. So I would use these values to find, this is the IROC, the rate of change, or average rate of change actually, of 4.5. We just do the simple slope formula. So f of 5 minus f of 4. Okay, so I am going to, of course, this won't give us an exact instantaneous rate of change, but it gives us a good estimate because we're as close as we can to 4.5. So 21 minus 12 over 1 is 9. Okay, so when we explain its meaning, we need to look at what kind of scenario we have in the units. One lazy day, Uncle Si decides to sit in a shade tree next to a road by the swamp and count the number of ducks which cross the road. The date in the table shows the accumulation of the number of ducks crossing the road at each hour after 9 a.m. Okay, so here's our explanation then. At 4.5 hours, after 9 a.m., because that's what this is, approximately 9 ducks are crossing, or maybe I should say have crossed, no, are crossing the road per hour. It's kind of a silly scenario, but it's all right. Okay, number 17. So these you will do, it's asking you to just find the derivative of each of these. Find the derivative of each of these and use your table to fill in the missing values. So I'm going to have you work this one on your own because we've done the product rule here and we've done the quotient rule enough that those would be good practice for you to try on your own. (24) The graph of f prime, the derivative of f, which is defined for all x values shown on the right between -2 and 7. What are all values of x for which f has a horizontal tangent line? So now we know what we're looking for. We're looking for where would we have horizontal tangents. So I'm looking for where it's changing from a negative to a positive slope. I see one there at -1, one at +1. This would be a sharp corner, so that would not count as a 0 slope. Because horizontal tangent, of course, we're thinking, where is the slope? 0. That's what we're thinking about, a 0 slope. Oh, and right here's one more. So we have 3, -1, 1, and 6. B. Okay, find the instantaneous rate of change. IROC means we do the derivative and then evaluate it at this point. So the derivative of our function would be 2x minus 3. If we evaluate it at this point, it will be 2 times 4 minus 3, and 8 minus 3 is 5. Find the average rate of change, AROC. That's another word for slope. So you're going to find the slope at that point. So I'm not going to do this one because I think you know how to do f of 1 minus f of -2. 1. So of course, to find those y values, you will plug it into your function, get your y values, and finish solving from there. Write the equation of the tangent line. That's our EOT. And of course, to find our EOT, we need our POT. So at 2, let me write it this way, f of 2. To find that y value, we're of course just going to go up to our original function and plug that in. 2 squared is 4, minus 6 is -2, plus 3 is 1. SOT just means the derivative at 2, and we actually have already found our derivative, so I'm not going to do it again. We found that in part 1 up here, so I just have to plug in the 2, which is also 1. So now we can write our EOT, y minus 1, slope x minus 2. Okay, this is the one that's tricky. I remember working this one because we have, okay, let's read it carefully. So using f of x above, okay, our original function, If k of x equals f of x divided by e of x, find all values for x where the tangent lines to k are horizontal. Tangent lines, so you should be thinking derivative, that's how we get tangent lines, are horizontal means a zero slope. This is talking about the tangent line. It has a zero slope. So of course, first we need the derivative of k of x. So that's our first job. So I'm going to, I see a quotient rule here. So low d high minus high d low. The derivative of e to the x is derivative of the stuff, which is just 1. So I didn't write the 1, times e to the stuff. All over low squared. So we have the first part. We have the derivative of k of x. Now, since it's horizontal, I want to set this equal to 0. So I'm going to need to rearrange this because I'm going to have to try to simplify this. So I notice I have an e to the x in both of these, so I'm going to factor that out. I'm going to put an e to the x. It's going to help me simplify a little bit. Because I have an e to the x divided by an e to the x, I can get rid of this squared because I can cancel one of those out. So here's how I'm going to simplify it. Get rid of that one, get rid of that. F prime of x. I believe I have this already. It's up here at the top. This is my f prime of x. Remember when you have a short answer, A, B, C, D, that you can use anything on this page. So this is our f of x function. That's why we use different letters a lot in calculus, so you know specifically which function we're talking about. Since it's talking about f prime, I'm at the top. This is what I'm going to use. I'm going to plug in that function right there. For my original, that's the original one at the top. And I have one of those e to x left. I got rid of the squared because I had 2 of them and I canceled one out there. Okay, I really would like to solve for x here. I'm going to multiply by e to the x on both sides because e to the x times 0 is just 0. So that helps me get rid of one thing there. All right, let's see if we can simplify this. I have a negative x squared. If I distribute this, this is a positive 3x plus 2x. That's going to be 5x. And then I have a negative 3 and a negative 3 if I distribute that out. So that'll be negative 6. Ooh, I'm getting closer to something that looks like I can solve. This looks factorable. I don't like factoring with a negative though. So I'm going to change the signs by multiplying by negative 1. That looks easier to factor. So now, easy factor problem. I have 2 x values, 3 and 2. So I'm going to go back to the problem, make sure I found it. Find all x values. Okay, these are x values where the tangent lines to k are horizontal. Because I was double checking to make sure it didn't say find the points or the coordinates. Because if it asked for the coordinate, I would need to find the y value that would match it by plugging it back in. But it just asked for the x values. So those are all the x values where the tangent lines to k are horizontal. I feel like that one's a doozy, but it's fun. Okay, last page is doing the same things but from a graph. Let's see. This one is a product rule. So you can do that one. This one is a quotient rule. You can do that one. I would like to do C as our final problem today because of the radical. Sometimes that confuses us. Remember I told you to always rewrite a radical so that you have it as an exponent form. That way it's easier to do the derivative. Of course, we're going to do a product rule here. So we're going to kick off the first times the derivative of the second, so d2 plus the second times d1. first times the derivative of the second plus the second times derivative of the first. Okay, m prime of 9. So I'm looking for g of 9. I'm going up to my graph up here, g graph 9, the value there is 3 times a half. I'm just going to leave that there for now. And then remember, this means to take a square root, and a negative means to do a reciprocal. So I got a couple things to think about here. I'm going to plug in 9, take the square root of 9. That's what a 1/2 power means. So that's 3. Square root of 9 is 3. The negative means do the reciprocal. So this is going to be 1/3. 9 to the 1/2 power. That means take the square root of 9, which is 3. And then g prime of 9. So that means I'm going to go to the g graph at 9, and I'm looking for the slope because it's g prime. So I'm looking for the slope of this line. Well, it looks like it's up 2 over 1. So my slope is 2. All right, these will be 1. So I have a half plus 6. So a half plus 12 is another way of saying the same thing. 13 halves, or if you like decimals, you could say 7.5. 6.5, sorry. Same thing, whichever decimal or fraction is fine. I like to leave it in fractions. I think it's easier. Okay, well, good luck on your test. I hope you spent some time on this review. Don't forget to do your Delta math, and I look forward to seeing how well you do on your second test of the year.